In this lesson, we're looking at the properties that rectangles possess. So you'll see the rectangle's already drawn in. If you haven't given yourself a chance to do so, pause the video and go ahead and plot RECT. Now, rectangles have all the parallelogram properties. So before we really get into the new properties, let's recap some of the old ones. So remember, one property that parallelograms have is that opposite sides are congruent. Another thing that's true about the opposite sides is that they're parallel. Remember, we learned about diagonals, which cut across a four-sided shape. And in this case, diagonals bisect each other. And then opposite angles are congruent, while consecutive, now remember, consecutive is just another word for next to one another. Consecutive angles equal 180 degrees, aka they're supplementary angles. Remember, that's two angles that add up to 180 degrees. Now, all those properties still apply to the rectangle. The rectangle just has a couple more properties that make it a little bit more special than the parallelogram. We're kind of making our way down a quadrilateral chart, if you will. We started with just four-sided shapes in general and then talked about a trapezoid, and we ventured off to the isosceles trapezoid. From there, we also talked about parallelograms. Now today we're talking about rectangles, which some of you may recall from prior lessons or just other years in math or different classes too, where rectangles have come up. So the first thing we're going to look at, though, is the slopes that they possess. So if we look at the slope of all of these, now remember, the slope is so nice when we have a graph because we're basically just counting up and over. So like RE here, we're counting up 3 over 3, which simplifies to 1. And you can write it as 1 over 1 or just 1, either way. If we look at EC, now remember, we're reading it left to right. So we're counting down over. Now in this case, we're counting down 6 over 6, which simplifies to -1. Now if we repeat that process again, CT, even though it's saying CT, we're still reading left to right. So we're really going up 3 over 3. Simplifies to 1. And finally, when we look at TR or RT again, no matter what the order is, we're reading left to right. We're still going down 6 over 6, which simplifies to -1. So we definitely know that this is a parallelogram because we see that the opposite sides, like RE and CT or EC and TR, they're the same, which means parallel. Remember, we can always tell parallel lines based on the slope. But what we should also notice about these slopes is that it's not just parallel. Comparing the two sides that are next to each other, again, that word consecutive, those are negative reciprocals of each other. So if they're negative reciprocals, recall, they form perpendicular lines, which form right angles, which means all of these are right angles. So our first unique property, so I say unique because the parallelogram or the trapezoid do not possess this every time, is that consecutive sides are perpendicular and all angles are congruent right angles. So that's something special to just the rectangles. So now all the angles, not just the opposite angles, are congruent. They still are, and they're still the supplementary angles that are consecutive, but every single angle is equal to 90. Now we're going to do something a little bit different here. We're going to check out the diagonals of this shape. So I'm just going to draw in my two diagonals. So we have here RC and ET. So remember, they're just the opposite letter points connecting to one another. So in this case, unfortunately, we don't have any kind of horizontal or vertical line path, so we do have to use our distance formula. So when calculating the distance formula, remember that's the one under the radical. For RC, we're going to use the points of R and C. So -2 and 7. So we're going to have -2 subtract 7 squared plus, let me just check, I believe it is 4 subtract, 4 subtract 1 squared. And we're going to check out how that simplifies. So remember that double negative is going to make us a -9, but when we square that, we'll still end up with a positive 81. And we'll have 4 subtract 1 is 3. Square it, we get 9, which is equal to the square root of 90. Now the square root of 90 is not a perfect square, so we're going to leave it just as is. We're not creating any additional work for ourselves in this case. But we want to repeat the process for the points ET now. So we're using the point with 1 and 4. So 1 subtract 4 squared plus 7 subtract a -2 squared. So we use the points specifically from E and T in this case. And we're going to simplify this up a bit. So we have -3 squared is going to get us 9 plus double negative here makes a positive. So 7 plus 2 is 9 squared. So 81. And again, we get the square root of 90. Equal lengths indicates congruency. So another unique property that's just true for rectangles so far is that the diagonals are congruent. And last but not least, one more thing is we're going to just take a quick peek at the two slopes of the diagonals that we've drawn in. So we could use the slope formula or we can count. So I'm looking at RC and I'm going to go down 1, 2, 3. And then over 1, 2, 3, 4, 5, 6, 7, 8, 9. So for RC, we're going down 3 over 9. And if we want to be safe and simplify that, we're going to get a -1/3. And to look back, so don't mind me as I go back to count quick, but now we're looking at ET. Now remember, still left to right, that means we're going down. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9 over 3. So going down 9 over 3, we simplify and get -3 or -3 over 1. Now be careful. Are these diagonals perpendicular? While they're reciprocals of one another, they're not changing the sign. So answer here is no. They are not negative reciprocals. Now, that doesn't mean that these can never happen, but it just means it's not a property necessarily. Basically, the 3 properties that we've seen that are unique to rectangles are that they have congruent right angles, so their slopes are going to show those perpendicular sides for the consecutive sides, and the diagonals are congruent to one another. So just recapping that on the next side of our sheet, we have 4 congruent right angles and that are diagonal, so crossing the 2 sides, they're congruent. So let's look quick at some of the properties that tie back to this. So we have in the rectangle RSTU, it is known that RS equals 12 and ST equals 5. What is the length of the diagonal of SU? I would always recommend drawing yourself a picture when it comes to quadrilaterals. It makes life that much easier. So we have RSTU. Now your rectangle never has to be drawn to scale. It never has to look perfect. It just has to do the best job it can to help you provide that visual. So RS is 12 and ST is 5. But our goal is to find the length of SU. Now you have to think about these properties that we've just talked about to see what really could help us here. What's going to stand out? So one thing I notice is that it still has all the parallelogram properties, which means this side is 12, UT is 12, and RU is 5. And the new property to rectangles is that we have right angles all the way around. To finish this up, we may be able to notice one of our familiar shapes as a right triangle, and we're looking for SU. So the question is, how do we solve for a side missing in a right triangle? We go back to Pythagorean theorem. So 5 squared plus 12 squared equals x squared. So we have 25 plus 144 equal to x squared. We get 169 equals x squared. And when we take the square root of both sides, that's going to show us that SU is equal to 13. So this, remember, ties right back to our former properties as well. In the next exercise, our rectangle is already given. We want to calculate the slopes of the 4 sides. So remember, that's just us counting our boxes. So if we look at each of the 4 here, if we start with EF, when I count here, I'm counting up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8, 9. So up 6 over 9, which simplifies to 2/3. We can do this for FG. FG is going to be going down this time because left to right, we're going down 1, 2, 3, 4, 5, 6, and then over 4. And if we do it again for GH, it's going to again be 2/3. And finally, EH is going to be -3 over 2. Now, luckily, the slopes is enough to prove that this is a rectangle. By seeing these slopes, we not only know it's parallelogram because the opposite sides are parallel, but because those consecutive sides have those negative reciprocal slopes, we've just shown that there's 4 congruent right angles. Okay. Now, just to kind of bring back some of our former properties and look back, we also can calculate the midpoint. So the midpoint, remember, the formula is when we take x1 plus x2 divided by 2 and y1 plus y2 divided by 2. If we did that for the 2 diagonals, so remember diagonals meaning it's EH and EG, when we do this, EG, it's going to be a -6 plus 7 divided by 2, as well as a 2 plus 2 divided by 2. And in our case, that's going to make this midpoint 1/2, 2. Spoiler alert, if you do it again for FH, you're going to get the same thing. Now remember what that tells us. It tells us that the diagonals bisect each other. It doesn't show congruency. It doesn't show parallel or perpendicular. It just shows that bisected part. So that's why it's only enough for a parallelogram, not enough to do the full rectangle. Because remember, the rectangle has all the parallelogram properties, but it's special, so we have to keep that in mind. If we were to calculate the next part here in the lengths, what's nice about calculating the diagonal here of EG, you can count. It's on a straight horizontal path, and when we count that, it's going to get us 13. And if you were to use the distance formula, which you would have to show for FH, it's still going to get us 13. Now, Together, it's enough to prove it's a rectangle because you're showing it's a parallelogram with those special properties. Okay. The final thing that we could have is something